All right, today in class we continued our work with implicit curves. So x cubed plus y cubed equals 6xy makes this fish-looking curve right here. So if we take this derivative, it's going to be 3x squared dx dx. We don't need to write that. Plus 3y squared dy dx equals, and then we have this last thing on this side, that is a product. So we're going to have to make ourselves our little table. 6x is my first function and its derivative is 6. Y is my second function and its derivative is dy dx. Or do our product rule. So I have 6y plus 6x dy dx. Now it says find dy dx. What that means is we're going to solve this for dy dx. So we're going to have to move some stuff around. We'll put dy dx is on one side. We're going to put everything else on the other. So I'm going to rearrange this a little bit. I'm going to leave this 3x squared over here, but I'm going to move the 6y from the other side. And then I'm going to put 6x dy dx. And I have a minus 3y squared dy dx. Now we're going to factor a dy dx out. So it's going to look like this. 3x squared minus 6y equals 6x minus 3y squared. And then all of that, we're going to factor dy dx out. And so now all I have to do is divide off that 6x minus 3y squared, and I get dy dx equals 3x squared minus 6y over 6x minus 3y squared. We can reduce this. Notice all of those things divide by a 3. It's not necessary to reduce, but we can if we want to. I'm actually not going to because I'm looking ahead. And looking ahead, I happen to see that in the next problem it says find the equation of the tangent line and normal line to the graph at this point right here. Notice that denominator is 3, and I really want those 3's to start canceling out. So we have, this is our slope. We have our slope right here. This is slope. Remember, when we take the derivative or dy dx, we get the slope. So we're to write the equation of the tangent line. The tangent line, we're going to say y minus 8/3 equals whatever we find our slope. Our slope is x minus 4/3. We got to plug in our slope, so we have to figure out what our slope is. So we're going to say dy dx. And I'm going to plug in my x and y values. So I have 3. And my x value was 4/3 squared minus 6. And now I got to plug in y, which was 8/3. And then the denominator is 6. The x value again was 4/3. And I have minus 3. And the y value again was 8/3. This is pretty common. This in particular problem does come straight from the AP test. In particular, it comes from the constructed response. Even though they gave them the fraction 8/3 to plug in, it is not that terrible to start reducing things because there's a bunch of everything divides by 3. So right here, I've got the 3's canceling there. This 3 is going to cancel, and that's going to become a 2. So the denominator is actually 8 minus 8. Oh, I missed my y squared. That's why. That's a squared right there. I knew when I did my practice problems I did not get 0. So I have minus 3, and I have the 8/3 squared. Okay, Now we can start fixing this. So I'm going to have 3, and it looks like I have 16/9 minus, this is going to cancel, minus 16. I have 8 minus, looks like 3 times 64/9. So one thing we can do is I can reduce some of these things. It looks like the denominator is going to reduce a little bit more. So this is going to go away. That's going to be a 3. That's going to go away. That's going to be a 3. So now this is helpful because my denominator is 3. So if I make everything a denominator of 3, I can combine all my terms. So it's going to be 16 times 3, I think, is 48. So I'm going to write this as 48/3. 8 times 3 is 24. So I'm going to write this as 24/3. So now I can combine all my terms. I have 16 minus 48, which is negative 32. And then on the bottom, I'm going to have 24 minus 64. So that's going to give me a negative 40. This is not a terrible fraction. That's actually relatively friendly. That is the fraction, if I divide by 8, 4/5. So 4/5 is my slope. And then to write the normal line, everything looks the exact same except the slope. So I have y minus 8/3 equals, the normal line is the opposite reciprocal, so negative 5/4 x minus 4/3. So that is example 4. And again, this came from the constructed response items on the AB test. It's usually like item 4-ish usually on those tests. So it is always on there. All right, example 5. Find dy dx at the point 0, 0 of the function tangent x plus y, all inside that tangent function, equals x. So we're going to take this derivative. Now we're going to do this derivative. We've got a chain rule going on, so we have to be careful. So the derivative of tangent is secant squared. So I'm going to write secant squared, and I'm going to do x plus y. Leave it alone. So x plus y. Now I have to say times the derivative of the inside thing. So the derivative of x is 1. The derivative of y is dy dx. All right, now I say do the derivative on the other side. The derivative of x is just 1. And now I'm going to solve for dy dx. So if we look at it, 1 times anything, it looks like I can probably just divide the secant squared thing off first. So I'm going to write 1 plus dy dx equals 1 over secant squared x plus y. Now let's think about secant. Secant is the reciprocal of cosine. So let's fix that. That is 1 plus dy dx equals cosine squared x plus y. It's always easier for us to deal with trig functions in terms of sine and cosine, so we do that as often as we can. So now when I solve for dy dx, that is going to give me cosine squared x plus y minus 1. And so now it says evaluate dy dx at the point 0, 0. So that means I'm going to plug in 0 for x and y. So dy dx such that x equals 0, or evaluated at x equals 0. We're going to say cosine x plus y, 0 plus 0, cosine of 0 is 1. So I'm going to say 1 squared minus 1. Oh, it looks like 0 is what I get. All right, last example is find d squared y dx squared. So that means take the derivative twice. So there's going to be some tricky algebra going on here. We're going to have to do some replacement and some substitution. So we're going to start with the derivative the first time, the power rule. So we're going to have the 3 comes down, becomes 6x squared, dx, but we don't have to write it, minus 6y, but I took derivative y, so now I need dy dx, equals the derivative of 8 is 0. So keep in mind the idea here is to solve for dy dx. So I'm going to write 6x squared equals 6y squared dy dx. And now I'm going to divide the 6y off. And notice those are 6's on both of them, so I'm going to simplify that. This will become dy dx equals x squared over y squared. So that is the first derivative. Now, I need to take the second derivative. Oh, and I somehow added an extra square in there. This is not squared. Sorry about that. Okay, so now I need to take the derivative again. So we're going to take the same problem, and I'm going to say dy dx equals x squared y. And what I want to do is I want to take that derivative again. So I'm going to, when I take the derivative dy dx, I take that derivative. That is going to become d squared y dx squared. That's, you take the derivative of the derivative, you get the second derivative. Okay. Now we have a quotient on the other side. So I need to make myself the little table we've been working with. So the first function is x squared and its derivative is 2x. Technically dx dx. Second derivative is y and its derivative is dy dx. So we're going to do our quotient rule. I have 2xy minus x squared dy dx all over the denominator squared, so all over y squared. Now, this is true, but notice inside this function, I have this dy dx. So I have to come over here to what we said dy dx was, and I need to plug it in and simplify as much as I can. So let's try that. So I'm going to say equals 2xy, I'm going to leave that alone, minus x squared. And I'm going to plug in the x squared over y, all over y squared. Now we have this fraction in a fraction thing going on, so I need to multiply everything by y over y so that I can get the entire numerator in the same form. So if I multiply by a y over y right there, I can then move these extra y's to the denominator. So now this is going to look like this. It's going to say 2xy squared minus x to the fourth all over y to the third. This comes up in the multiple choice items. And the multiple choice items, this is how I see these reduced. So the key is if you have a complex fraction right there, you're going to want to put it all together under one term. That tends to be how they reduce them. They very rarely leave them that way. So that's what we're looking at. That's what we're practicing. We will do some more practice problems in class.